All right, guys, this is going to be the notes for 1.4. As we go through and look at this first assignment, it's really important that we understand that we're kind of trying to get those juices flowing. So hopefully this feels like something that you've seen before, you remember kind of working with it, but it really does lay the groundwork of a lot of the stuff that we're going to do later on this year. You know, we're constantly taking equations and we say solve them for y. As we go to solve those equations for y, it's fundamental that we know how to do that. And this is really that groundwork for solving equations for a specific variable. So I'm going to take you through a couple of example problems that kind of just give you that sense of what we're really trying to do. Now, a fundamental idea that you probably already recognize is when we talk about simplifying, right? So if I ask you to simplify something, you know, we're talking about combining like terms and distributing and that kind of stuff. And we often will refer to the idea of Pemdas, okay? Where we start with our parentheses and then our exponents. We multiply and divide from left to right, and then we add and subtract from left to right. And that's our Pemdas, our simplification process. So let's take an example like 3x plus 5 times 2x minus 8 and plus 5 squared. If I were to go and try to simplify this, okay, I would start with any parentheses. Right here I see some parentheses. Inside those parentheses I can't do the 2x minus 8. That's a subtraction I can't do with because they're not like terms. But I can certainly do the distribution here. Okay, but because there's no exponent, you know, that's what my parentheses would ask me to do, is that distribution. Okay, so I'd still have my 3x plus 10x minus 40. Now over here, I have this exponent that needs to be simplified, and so 5 squared is really 25. Now I'd be looking for any multiplication or division that's left in the problem. There is no multiplication or division except for 3 times x and 10 times x, but I can't do those because I don't know what x is. Then I look for addition, subtraction. Really, I'm talking about combining like terms. This is 13x, and a negative 40 plus 25 would be a negative 15. Now this is fully simplified. I can't go any further until I know what x is. So this is at the heart of what we talk about when we say we want to simplify something. However, today our focus is going to be on a different word. We're going to focus on solving. Now, when we solve something, we're talking about taking something that has an equal sign. That's a really big deal. It has to have that equal sign. And we're trying to isolate a specific variable. Get it completely alone. And that's how we go about trying this idea of solving. And so if I took this same equation, 3x plus 5 times 2x minus 8, and I said it equals 5 squared, okay? Fundamentally, I can't go about this necessarily the same way. Now, there's some of the simplification that I can do, like this distribution makes sense, and that exponent. I can still simplify those in their individual pieces. So I get my 3x plus 10x minus 40 equals 25. I can even look at combining some like terms here and get 13x minus 40 equals 25. But now I'm in this spot, this place, where there's nothing left to combine without crossing the equal sign. So as I go to move things across the equal sign, I'm not going to do it in the same order that I did Pemdas. I'm actually going to reverse and flip the order and do what I call SADMEP. I'm sure I'm not the only person. We're doing Pemdas backwards here. So when I look at my variable, which is x right there, and I start saying, what do I need to do to solve for that x? I want to start not with parentheses and exponents. I mean, that's a simplification process, but that's not a solving process. When I go to actually get the x alone, I want to look at any addition and subtraction that I can do to simplify the side of the equation where the x exists. Over here, I see that I have 13x, that's a multiplication, and I have minus 40, that's an addition subtraction problem. So I'm going to go ahead and add 40 to both sides. On the left side, that's going to zero out my 40. It's important we understand that when you add and subtract, you're shooting for 0 multiplication division, we shoot for 1. So in this problem, now I have 13x equals 65. And now I've done my addition and subtraction. The next step of SADMEP is if there's any multiplication or division. Here, there's a multiplication of 13 times x, so I will reverse that, or go to a 1 by dividing by 13. And that's going to give me that x would equal 5. Okay? It's important to understand that when we're solving, we're not going to start with our parentheses every time. In this problem we did because there was some simplifying to do, but it's not typically that way, and certainly you shouldn't always expect it to be that way. Okay? So what we're going to do now is we're going to go ahead and clear this. Let's see. I go. There we go. All right, so let's get ourselves some new space. As we go in and we look at some example problems, I'm going to try to really pull from what you're going to be seeing in your assignment. One of the first things that you're going to see in your assignment is these equations, these formulas that we're used to seeing in a traditional format. Like, for instance, the area of a triangle. Whoops. Area of a triangle is 1/2 base times height. And this would be question number 4. And it says, first thing it wants us to do is to rewrite this formula so that what we're finding is b. Basically, we want to take this equation and turn it into a b equals equation. And so we look at how do I remove what's with it, or solve so that the b is no longer crowded. If we look really closely, we have to focus on the relationships here. I can see that b and h are multiplied. I can also see that b and 1/2 are multiplied. So this is important fundamentally to understand. But that is a strictly multiplication type of problem. And so it doesn't really matter who I get rid of first. I have a 1/2. I also have an h. But they're both multiplication. And in the terms of SADMEP, I don't have addition and subtraction to move. I do have multiplication and division to work with. A lot of us have an initial reaction to divide by h and get rid of it. I'm actually going to suggest that we focus on the 1/2 first. Okay? Now, normally we say if we're multiplying, we're going to reverse it or cancel it by using division. And that's generally true, but remember, our goal is to turn the 1/2 into a 1. Because if I had 1b, this would be a lot simpler. So how do I turn a 1/2 into a 1? Well, we're going to multiply by 2 over 1. We're going to use its reciprocal. If it was 3/4, I would flip it and use 4/3. To do that on the right, I have to do it on the left as well. Here, a 1/2 times 2 should cancel or simplify to 1. I now have 2a equals b times h. And again, I'm left with this question of how do we remove the h? It's multiplication, so I need to turn that into a 1. How do you turn an h into a 1? You divide it by h. H over h is 1. And so that again simplifies down to 1, leaving me with just b equals 2a over h. So those are the kinds of things that we're after today. Rewriting the formula so that we can work with the algebra that exists inside the problem. Now, question 4 says, okay, now that you've done that, what would the base be if the height is 6 inches and the area is 24? Well, this formula is really built for doing that. 2 times we said the area was 24 square inches and that the height was 6 inches. Well, 2 times 24 is 48, divided by 6 would be 8 inches. So there are actually 2 answers to question 3 through 10 as you go through those different questions. Okay? So it's all about isolating and then plugging in numbers to see what we would get there. Okay? So let's, I'm still not totally sure. Oh, no, hold on. Oh, not what I wanted. Still trying to, oh, that's bad. I'm still trying to figure out this new technology and just making sure that I get the most bang for my buck. in terms of how I'm using this. So for now, we're just going to add another one. And you guys will figure out, eventually I'll figure out how to do this without adding more pages. Let's look at a couple of really interesting examples that go on a little bit closer towards the end of your assignment. We're going to look at question number 19, and then we're going to look at question number 26. Okay, so 19 has a really interesting shape. Whoa, what did I do? Has a very interesting shape right here. It's like a cylinder that got cut at an angle. Okay, and they're asking us about what's called its lateral surface area. So it's the area around the outside edge of the curve. You can imagine wrapping it with paper around, or like the label on a soda can, that type of label. And they give us the formula that the surface area on the lateral edge is equal to pi r times the quantity h plus k. Now, I'm not going to get too far into this formula right now. I just want to work on the algebra that you would use to rewrite it. And they're specifically asking us in this problem, let's use a rainbow, to find h, to isolate this equation for h, the height on the short side. For us to do that, we're really going to have to think closely about the algebra of Pemdas, and in this case, SADMAP. Okay? So this is a really good question because it really pulls us to go slowly. Is there any addition subtraction in the problem? Well, the answer is yes, but the h plus k exists inside of a parentheses. I'm not supposed to do parentheses until the very end of this problem. So what you have to realize is that every time you're looking, it's like an onion and you're looking at the layers. Don't mind the ogre joke. Okay, so we're looking at the layers, we're seeing the h and k, the addition is existing inside the parentheses. I can't touch that. So I come to the next layer and I'm looking for any multiplication or division I can do. Now, I see that pi is being multiplied by r, is being multiplied by my parentheses. I know a lot of people would normally want to distribute the pi r. The truth is, because I want h by itself, that would just be putting more stuff with the h, and that's counterproductive. Since that's all multiplication by the parentheses, I can remove all of that by division. And rather than dividing by pi and then dividing by r, I'm just going to divide both sides by pi r. And if you think about it, that should look like something that you would say a pi cancels a pi and an r cancels an r, leaving me with s over pi r equals, now h plus k no longer needs the parentheses because there's nothing outside of it. So if I'm looking at this, now I can return back to the top of SADMAP and say, hey look, that addition subtraction I couldn't do before because it was down in the parentheses, it's no longer in the parentheses. All I have to do to solve for h is subtract a k. It's important we recognize that this k was not part of this fraction. And so when I minus the k, my formula will look like s over pi r minus k. And that k is not part of the fraction. It really implies the order of operation that we go through and do. Now you're also given some numbers on 19. They tell you that the r is 2, k is 3, and s is 50 centimeters squared. And so if I come in and I put those, so first we're going to say that's our answer, and then h is, s was 50 over pi times the r was 2, and we minus k, which is 3. Now, when we put something like this into the calculator, it's really important how we do it. You're going to need another set of parentheses around the pi times 2, or the other way that you can do it is just do pi times 2. That'll give you roughly 6.28, and then take 50 divided by 6.28, and then you can minus the 3. So be really careful. Don't just do 50 divided by pi times 2. It will misinterpret how that's supposed to be put in. If we evaluate that in our calculator, we should get a number roughly 4.96, okay, centimeters. Again, I'm not as nervous about the plug-in. I really want to focus on this first half where we're doing the algebra of rewriting the equations. All right, I said the last question we look at is number 26. I know this video is probably taking a little bit longer than you were hoping, but I really want to make sure you had feet underneath you, really helping you out, making sure you're in a good place. So 26 starts with 4x plus 7y. Let's come in here. 4x plus 7y. Ooh, I'm losing it today. 26. All right. 4x plus 7y plus 5xy equals 0. Plus 5xy equals 0. Okay. Fundamentally, this is a type of problem that is going to come up off and on throughout the year. It's not going to be something you do every assignment. Probably every couple chapters, this will pop up. And if you don't remember it, you'll have no idea how to deal with it. So I'll always try to remind you, but be aware. This, where we're trying to solve for y, okay, so we're going to solve for y, okay, this is important. When there's more than one y in the problem, sometimes we end up in this spot that we're going to look at and we're stuck, okay, and we're going to talk about how do we fix it. Again, this will come up again and again throughout the year. It does seem sometimes random, but it's fundamental to how we solve algebraic problems. Now remember, when we do this type of work, we want to do SADMAP. Okay, so we're starting with any addition subtraction that we can do to get the y, or in this case, both y's, more isolated. I think we can all claim this 4x right here isn't doing anything with the y's. I might as well move it, and since it's a positive 4x, if I subtract 4x, I should zero that out. But to do that, I gotta do both sides. That leaves me with 7y plus 5xy equals negative 4x. Now the fundamental problem I have here is that I can't combine the 7y with the 5xy because they aren't like terms. So then how do I do this? And some of you will say, well, subtract the 5xy and divide by 7. Because you say, I can isolate this y. But if you have y in the answer, that means it's like saying, my name's Mr. Welch, and I'm the guy that you call Mr. Welch. That's not a very clear definition of who I am. To define y, we need something that doesn't use its name or use it in the definition. I just think of anything. You say, oh, red, it's the color that's red. That's not a very good description. We need something more. So whenever we end up in a problem where we have multiple of the same variable that we can't combine, we're going to do what's called a GCF factor, greatest common factor. Okay? So ask the question, what does 7y and 5xy have in common? All that they really share is the y. So I'm going to create a single set of parentheses. I'm going to take that common factor and put it on the outside. Now as I fill in this inside of this parentheses, my focus is on making sure that I still can create the 7y and the 5xy. So if you think about distribution, right? If I think about how would I create a 7y? Well, y times 7 would be 7y. And y times a 5x would be 5xy. Now I need an addition sign because it's all positive up there. Ask yourself the question, if I distribute the y, would I still have 7y plus 5xy? The answer there is yes, I would. Well, now how many times do you see the letter y in the problem? Just once. I can isolate this y and get it completely alone by referring back to the process of solving, SADMAP. Okay? There's no addition subtraction with the y, but there is a multiplication between the y and this parentheses. If I divide by 7 plus 5x, this should become a 1. 7 plus 5x over 7 plus 5x should leave me with just y equals negative 4x over 7 plus 5x. Not all the problems are as complicated or involved in that. And to be honest, once you know that pattern that you just pull the y out and divide by whatever's left behind, it's not a hard problem. But if you have no idea how to approach it, yeah, it's a tough one. I'm not going to lie, it's a bit of a beast. So hopefully that's going to help get you through. Then on 26, they still want us to plug some numbers in. If we plug in, they gave us an x value of 1. So if we said y equals negative 4 times 1 for my x over 7 plus 5 times 1 for my x, I'd get negative 4 over 7 plus 5 is 12. And that's roughly, we're going to simplify down to negative 1/3. That would be our value of y. Could I have done it some other way? Yeah, there's some other ways, but our focus is really on this process here. Getting from any random equation down to where we've solved for the thing that we're looking for. Good luck, and hopefully we can get through that in class. Thanks.